How's it going, everyone? Welcome on in. We are going to be continuing our low rank adaptation fine-tuning today. My goal is to at least get the model have a reduced output, a loss. The loss reducing. That's the goal for today. I'd like to see a lower in the loss. And we need to create our optimizer and do a couple other things. Hey, how's it going there? Hello, happy Sunday. Welcome on in. Nizwa, good to see ya. Hope you're doing okay. Hope you had a good weekend so far. I'm going to quickly do the link share here. Copy this over to our Discord so we let everyone know that we're going to be doing some streaming today. Good to see you. Welcome on in. All right. So I want to go to general. Yep. And then, unless someone, nope. Okay. At everyone, we are, oh, not beef overflow. It always does that. I always like to do beef overflow. At everyone. There we go. That's right. All right. So where did we leave off? We left off right around here. Let's see here. Where we've got our parameters that we've defined. Right here. And we need to pass that out of our monkey patch into, hey, how's it going there? Said, hey, oh, said Hiraj. Said Hiraj, hello, welcome on in, good to see ya. Happy Sunday, Gokul, good to see you as well, happy Sunday. Hope you're having a good weekend so far. Hope you had a great weekend, good to have you here. We're gonna continue our low ranking adaptation for fine tuning. And we need to create a parameter list here, which we had that here, LoRA layers. We're going to say torch.nn.parameter list. And then we can append that. I think we can append it. We'll figure that out there. What's your Sunday plan? I'm going to do some streaming. We're going to do this AI fine-tuning of a large language model. Then afterward, I'm going to vacuum. I'm gonna vacuum. Hey, Epic Bloxpo, good to see you. Happy Sunday, welcome on in. Hope you had a great weekend so far. We're gonna enjoy our weekend here. I believe it should work. I'm wondering if, because I'm redefining this def here, so it should work as a closure. So I don't think I have to worry about doing anything extra here. What model are we going to fine tune today, buddy? Gokul, we are going to do the Quinn 2.5. It is an older model, and as you can see here, it has some issues. It works, however, it has some sort of weird looping thing problem here. Not a big deal, because we're just going to do this as an education. We want to see if we can fine tune it. I think we can. I think we're going to be able to. What are the parts with logic gates that looks like motherboards? Wait, yeah? Wait, what do you mean? What do you mean? There's a lot. Let's see, 1 second. Close that. I've got another window open here. I need to close that real quick. 1 second. Close. Close it, close. Oh. Uh-oh. Hey, is it still working? Okay. 1 second. What is this? What did I just close? I was like, I'm going to close all these windows. No, I shouldn't have done that. I'm just going to leave that right there and never mind, nothing happened. Okay. How do I learn them? All the logic gates that are on the motherboard? Wait, what do you mean logic gates on the motherboard? You've got various hardware components that live on your motherboard and you have slots, right? You've got slots that you can put expansion cards into. Things like GPUs, right? And memory slots, CPU slots. Hey, Loons, good to see you. Happy Sunday. Hope you're doing good over there. Welcome on in. All right. Hey, I was going there. 7 Allah. We should refine the model. When should I refine the model? Right now. That's what we're going to do today. That's our plan right now. We're going to refine it. We're going to try it out. So we have to do a few things. We need to have an optimizer. Optimizer equals torch dot, I think, and optim dot atom w. Can we do that? And then we need parameters. And I need to set those. I don't have them yet. I need to grab them from this. We don't have them yet, so I need to grab them here. Model. And then I'm only like 3 minutes late. Hey, yeah, you're doing good. Happy Sunday. Welcome on in. Like all the parts that look like motherboard, like sensors. I don't know. I don't know what you're talking about. It doesn't make any sense to me. I mean, you just have different hardware components, you put them together, and then it makes a computer. All right, what else is it? I mean, when do I need to refine the model? Oh, usually never. You usually never need to do it. The only time that here's the case that I can guess that would be worthwhile is when you need a very specific task for the model to be able to perform on a regular basis. And so you can fine tune it so that it more deterministically, more reliably can perform the task. That's a good way to do it. However, if you're already finding success with the model performing your task, you're good to go. You don't need to do it. Or what you could do, hey, Mecha. Hey, Mecha 69 or 96. Mecha 96, thank you for following. Oh, you're following. Oh, good to have you here. Are you using the Hugging Face library? I am using the Transformer library, which is technically the Hugging Face library. It counts as the Hugging Face library. It does. Can we use other optimizer like stochastic grading descent and muon? Yes, I think so. I think we could use muon. Optimizer equals torch.optim.muon. Parameters equals. We need to grab those. And then a learning rate equals some really small number. Some smallish number, right? So we need to grab that as well. So yeah, we can try out one of these two. Can we try? Gokul? Yeah, absolutely. We'll try using the muon. However, muon does have some restrictions. So we'll see if it will support this use case. It might. Never mind. You've never heard of muon? It's like the next level from after Atom. So Atom will find the best jumps to get your parameters, each of your parameters, to the best possible loss, or reduce the loss as maximum as you can with each parameter in your model. With muon, it has some sort of uniform jump across all your parameters, and apparently it performs better. I don't know about that. Hey, EMM, welcome on in. Thank you for subscribing. Good to have you here. Happy Sunday. Good to have you here. Hey, Mark Lemon. Also, you're here. Everybody's here. This is great. Good to see you, Mark Lemon. Happy Sunday. Yeah, we'll try the muon. We need our parameters, though, from this here. So we need to return the parameters real quick. Let's see. Model. And then we have our LoRA parameters. Yeah, LoRA layers. We can say LoRA layers. That's fine. Parameter list, and we see append, and then we need to just append only the layers. So we'll do LoRA layers.append. Here, I don't need any of these things. Wrong language. Let's see. Hide those for now, and then we need to append each of these. So LoRA in, and then LoRA out, like that. I think that'll work. Can combine both optimizer. Yes, you can. You can combine both of them. Isn't that neat, Gokul? Do you want to use both? We'll use both, okay? Dude, thank you so much for doing this. Will there be a VOD? Absolutely, John Madden. Yes, there will. VOD's available for free. Things like the Arduino. Oh, okay. Got it. Yes, so an Arduino going to be like a small microprocessor board, really tiny. And there's all these like modules that you could plug into it, usually through some sort of GPIO pins, right? General purpose IO pins. You'll plug those into each of those GPIO ports, and then you need to write code to determine what the outputs and inputs are going to look like on that. Because you can either transmit data through a baud rate or receive data based on a baud rate. Do you ever get hate comments? Well, I get sometimes, yeah. A little bit, a smidgen, not really though. I think mostly we're good. This channel's great. Yes, we can combine both, buddy. Yes, we can. All right, we'll do both. Where do I learn about them though? I don't know. I really don't. I learned them by buying them, and then I installed, a compiler back a long time ago, before Arduino IDE Studio existed. And I haven't done this for many years now, decades. It's been decades. So I don't know. I don't know. But good to have all of you here today. Thank you. Welcome on in. We do have a hackathon for those of you who are interested. We've got a Blocks hackathon that started today, blocks.ai. Agent hackathon, just go to blocks.ai, make an agent, and then submit it to the Discord. You're good to go. Who is LoRA? Oh, yeah. B-Nose, welcome on in. All right, so LoRA is, LoRA equals Low Rank Adaptation for Fine Tuning. That's what that is. Really, really simple. It's really straightforward. Can you tell us a little bit about your tech journey? Sure, absolutely. So those of you who are new here, my name is Stephen Blum, CTO at PubNub. Started this company many years ago now. We raised 134 million, Series E, 1 billion devices connected to my network, over 68 patent claims granted, and you can see them. You can see them right here on my profile. So if you're curious about that, jumping over to LinkedIn, and had a good journey, lots of startups. Tried it, it's free, Loons. Yeah, you got the lyrics down, and we're currently listening to the theme song right here. That was an idea from one of you. You're like, hey, we should play the PubNub theme song. I'm like, okay, all right, we'll do it. You still got the 100. We're doing good. Let's just say we're doing good. Epic Blocks though, we're doing good. And so journey in a variety of startups at Microsoft and more startups. So mostly just entrepreneurship through my life. For the most part, mostly entrepreneurship, you guys. Good to have you here. Okay. So let's jump into the next song here. Okay. You can buy DDR5 RAM now. Oh wait, really? That sounds expensive. It does. Oh, I saw exactly. They use the Tune AI, kind of use them without knowing it. Some workflows to generate images. Well, that sounds like a good plan to me. I think you could do that. Amazing. Why did you quit Microsoft? Oh, startups. More exciting, right? Starting your own business is way more exciting, right? So much more exciting. So yeah, I've been entrepreneurial, joined Microsoft. Then I wanted to, be entrepreneurial again. That's amazing. It is. I think it's great. So low rank adaptations, right? So LoRA, double check. Is that right? Did I get, so Jiminy. All right. So LoRA, not to be confused with IoT, which is low, something range, long range, something. In machine learning, I think it's low rank adaptation, right? Yep, low rank adaptation right there. If highly efficient parameter efficient tuning technique to adapt large pre-trained models like large language models or diffusion models like images, like you guys were just saying, like Binos was saying, to specific tasks or data sets. That's the idea. Buddy, can we build the agent that can predict the mule within 30 milliseconds? And is it possible, buddy, to build? I don't know. What is that? I don't even know what that is. Hey, John Madden sub. That's great to hear it. Thank you. Appreciate it. How will you be training GPU? I've got my local system here. This is my local Mac. It's Mac. So I've got an MPS. It's an MPS model. If you're familiar, it's just Mac has their own dedicated hardware. So I'll be using that. So do you enjoy entrepreneurship? I sure do, because it means I can work as much as I want and reap the rewards, right? That's one of the things is in some jobs, you can work as much as you want, but you don't necessarily get the same, economic benefit. However, if you have your own business, the harder you work, the better the outcome, typically. In quantum computer, there is a 0, 1, and 2. I love that. It's an infinity. It's not a 0 or 1 or 2. It's an infinity. So a qubit has spin, right? And it's sort of like a vector, maybe, I guess you could say, or a point, or a magnitude or a velocity. And it's an infinite value. And you can collapse that infinite value to 1 or 0 if you wanted to. Qubits are 0, 1, or both at the same, exactly, superposition. Loons know this stuff too. Yeah, ClaudeTube, there we go. Hey, ClaudeTube's here. Anasazi, welcome on in. Happy Sunday, good to have you here. We're gonna continue with our fine tuning here of our large language model. He's way off, but he's back. He's back. I know it's good for inference, but for training, is training LoRA relatively light? Yes, it is, because it's called low rank, right? Low rank means small matrices, right? Small matrix equals small number of params equals fast, right? That's what that means. Bonzupi, yeah. Good to have you here. Howdy. I fell asleep yesterday during stream. Oh, you did? Might fall asleep again today because it's late at night. Understood. Can we achieve the qubit state only 2 to 3 seconds? Well, if you had a quantum processor, I think that would be step 1. You need your own quantum processor. You could use a quantum processor with D-Wave. I believe Amazon also has some, or they have a partnership with D-Wave. Why is LoRA fast to train? Because they're small matrices, right? Adapter matrices instead of the whole model. Yeah. So we've got our adapter matrices right here. Right here. These are adapter matrices right here. Right here. Real easy. You should try QLoRa. That is, yeah, we'll try that after. This is, so LoRA is the original low rank adaptation for, which means small matrices, right? Against the large models. You only need teeny tiny, right? So you've got your pre-trained weights over here with your large language model, and then you sort of tack on an input and output matrix. And the rank is right here, which gives you a lower dimensionality. So it allows you to train real quick. Are we picking weights to modify at random? We're gonna find all the linear layers. So the idea is to find all the linear layers. And I need to go through and validate that all the linear layers have the correct dimensions, because it needs to have 2 dimensions. So that's what we're doing. QLoRa quantizes the model weights to 4 bits, so you need way less VRAM. Oh, basically LoRa, but actually usable for consumer GPUs. So that's what the Q is for. Oh, we're learning new things. All right. So in that case, we're good to go. No caps due to my infraction yesterday. Hey, Lions for Lambs. All right. Good to have Babby back. However, I'm here for the fun. Sounds good to me. What are your thoughts about quantum computing? Hey, how's it going there, Rashab? Thank you, Rashab, for subscribing. Welcome on in. Happy Sunday. You joined the right channel for software engineering. We do a lot of AI coding by hand on this channel. That's what we do here. See, the keyboard is real. It's real, you guys. Quantum computing, the hype is, it's real. It's just not practical yet because there's not enough qubits in order to optimize most of the world's common problems. And you know what? It's all the promise of quantum is currently being solved by AI right now. All the problems that were like, hey, quantum's gonna be able to optimize all these like healthcare things and optimize this stuff over here and all sort of like major industry things. AI is actually solving it for us already. So all the applications for quantum are being eaten up by AI right now. Isn't that crazy? I'm like, oh no, quantum had such promise. And it still technically does because it will be a dramatic reduction in cost of compute once we finally have a large enough quantum processor. So we don't have it yet though. And the adapter doesn't actually change the core model weights. So it's just kind of an extra layer, isn't it? Yes, it is. Bonzupi, yep, just an extra layer, you got it. So we got our extra layers right here. Right there. Basically 2 matrices right here. Your A and B matrices. I call them in and out. That's what I call them. If we have quantum computer in PubNub, then what is latency of your APIs, buddy? Oh, it'll probably be a little bit more because PubNub with APIs, we do communication, right? So we want to be able to transmit data. Quantum processors don't really do any of that. They're just they're solvers, right? They're solvers for very specific problems. And so I want to be able to use a quantum processor to make my technology better It's not real. It won't do it. It won't do it. It's not what I want. Quantum computer had GPU? Quantum computer has GPU. Quantum computer is its own specific silicon. It's its own specific silicon type. Quantum computers do not have CPU, GPUs. Yeah, exactly. They're not. They're their own thing. Qubits. It's like a application specific accelerator, right? Like an ASIC. You can kind of think of it like that. And instead of traditional transistors, it's got specific core segments in there that I believe can spin up a qubit, like a physical qubit. And we have a way to measure that qubit and to reset them. So that way you can sort of link all the qubits together. So they have something quantum-y, right? That's as far as I know about that. Hey, how's it going there? Hello, brother. Hello, everyone. Mr. Bumpy Pickle. Good to see you. Fiber Brine, welcome on in. Good to have you back. What's today's topic, man? We're going to continue with our low rank adaptation fine-tuning today. So we've got most of our model written. Now we just need to get it to a place that will work. We got the feed forward working. It works right here. We actually got the feed forward working. Let's see. Oh, wait. We can get our optimizer here. Let's hide that for a second. There we go. And it should work. So we've got it. Now we just need to train it. There it goes. Right? It's working. It's working, you guys. It sounds great. Qubit like storage and processing. What's known and unknown kind of. As far as model that to device. We don't have model that device. Hold on. Wait. Hold on. Line 85. What do we do? Model that. There's a device there. What are you did we mess it up? Oh, we did. Okay, one second. Here, we got to return model and layer. Oh, okay, right. Okay, so let's go model, LoRa layers. That should do the trick now, because it's no longer a tuple. It's no longer a tuple. Are you a professor, Mr.? I am an entrepreneur that is very interested in artificial intelligence. And we are currently doing some fine tuning using LoRA approach. LoRA approach. Low ranking adaptation. Hello. Welcome on in, you guys. Sandeep and Peace Lord. Happy Sunday. Good to have you here. Let us build our accelerated fine tuning model with LoRA. Wait, what'd Claude say? No, they didn't give it away for free. You got to access it on the cloud. Yep. IBM's got one. They're pushing quantum way harder than anyone else. I don't know about way harder. I know from a marketing perspective they are. Google is heavily invested. You've got D-Wave, and then you've got IBM, and a little bit of Microsoft. How was the day? We're doing good. So far, so good. Got the food. Food is cooking in the oven. Food prep. And so I need to, at some point, pull it out. Not yet, though. Like maybe in 30 minutes. Happy Sunday. You have more knowledge than my professors. Hey, from industry? Probably. From industry, because I've been doing this for a long time. Yeah, I've been doing this for a while. So yeah, over 25 years in industry. Hey, Dumbledore. Hey, Dumbledore, welcome on back. Good to have you in here. It's been a little while. Wait, tell us about how you built PubNub from ideas to implementation. I started by writing code that would allow apps to communicate, right? That didn't exist back then. There were no push notifications for these devices. Thank you for the hearts, you guys. Appreciate it. There were no push notifications for these devices, for the mobile phones, and I needed a way to communicate with them. It would be great to be able to have a web browser here, right? A website, and then be able to send data to the device, or have like an IoT device that's off somewhere and then sending data to my mobile phone and allow anything to communicate anywhere. And I needed to build a broker bus that was distributed globally for fast communication, and that's what I did. I built it over many years. Not married, nope. Show me how you're cooking. It's just oven cooking. It's easy. You just put it in the oven. That's it. It's really easy. 25 years and yep. Oh, yeah, exactly. Fiber brine, exactly. What is your company built on? It's built in C, and Rust. So we've originally C. Then I wrote my own replication model that globally replicates the data across all the data centers that Amazon offers. and then you connect to the closest data center with your device, so that way you get a really solid, fast connection. Like really fast. It's a real fast one, you guys. Also, thank you for everyone joining in. I do have a hackathon going on right now. Join our Discord, the Blocks AI hackathon, just started this week. The end date is June 10th. So you've got time now, you guys. You got time for the hackathon. Blocks.ai. I understand how it feels. Oh, yeah, okay. Let's see here. Trying to catch up with the chats, you guys. Buddy, that time, there is no Kafka for push notifications, right? Gokul, you remember. Yeah, there was no Kafka. There was none. There wasn't. So I had to build my own. All right. Good to have you guys here. So you have worked on the same code base for many years in PubNub. Yes. And it has been evolved. It's changed over time. So we had a lot of C. We had some Python. And then we had a little bit of Rust, and then we started doing a little bit more Rust, and then it just took over from there. Can you do any streams on web development based on HTML, CSS, and JavaScript? Yeah, I sure can. Absolutely. You aren't broken, bro. Just busy learning. Yeah, there you go. That's the way to say it. It just takes time. A little bit of effort there. So you pioneered real-time communication. I would say yeah. I would say I democratized it. Yeah. Made it accessible to everyone for low cost. If you read my previous comment, then buy tomorrow. All right, sounds good. Sounds good, the Dreamer. Good to have you here. Rust is very hard. It is, I know, right? It's a very challenging language, but it's worthwhile. It's worth it. Can you give me an extra example so that we can understand deeply about PubNub? Yes. All right. So, if you you've probably used it because over 1 billion users per month. You've probably used my technology. So if you've ever ordered food, right? If you've ever ordered food like on Swiggy or TalkShop, or have used any sporting app or gaming or multiplayer gaming, right? Multiplayer games, that needs communication, right? So if I want to communicate from one device to another device, I need to be able to have a way to do that. And that's what my APIs are for. That's what I do. This is my tech. And so you can build like chat experiences, see the car on the map that's updating in real time, multiplayer casino and betting, sports media updates, right? Games, healthcare, telemedicine. That's what I do. That's what I do. Do you have any group or broadcast? What is that? Do you have any group or broadcast? What is... Oh, yes. Yes, broadcast, yes. Yep, you can broadcast it to as many users as you want. A mega broadcast. Are you releasing for free? Yes, it is. It is for free. So it's free forever. We've got a free forever option here. Starting plan. Free forever, right? I told you, free forever. Right here, forever free. No credit card required. Up to 200 users or 1 million transactions, which is a lot. Man, you haven't not read my full comment. Please read it. It didn't show up. I don't think I saw it. Let me see. Channel activity. Yep, it's not there. All I have is read, and then Mr. Bumpy Pickle, and then if you read, and then it's empty. And then it's empty. It didn't show up. You gotta type it again, or you gotta type it differently. Thank you for clicking the hi button. Let's see. All right. The Dreamer, your message didn't show. It's not there. I don't see it. Okay. Good to have you guys here. All right, let's go actually get back into our terminal window here. And also, right, the Blocks AI hackathon starting now. Does Ably work the same? Yep, Peace Lord. That sounds, yep, exactly. Exactly, Peace Lord. Yes, you got it. I wanted something for my chat app. Oh, yes, you showed up right on time, Sandeep. There we go. Yep, you can do chat with it. Absolutely. You figured it out, Sandeep. Hello, Steven. Hey, Chaitanya. Welcome on back. Good to see you. Happy Sunday. If you read my previous message comment, then bye, man. If tomorrow we'll have a live. Yep, so Dreamer, your message didn't show up. It just didn't show up. What's the hackathon? Oh, yeah. So you just visit blocks.ai. You follow the instructions to build an agent, and then submit your agent on Discord. and you'll be entered in to win for a prize. That's it. It's really easy. How do you do live subtitles, Sandeep? I've got that ready for you on my GitHub. We've got this right here. It's technology I wrote 8 years ago, and I'm only using it now. Here. So you see 8 years ago, around 8 years ago here. And you just follow the instructions. So you can go to my GitHub here. Really easy. I'll paste the link into our Discord. Here we go, you guys. Under link share. Good to have you here. Hey, Ted! Repo link. There we go. There's the repo link. Swiggy uses PubNub from the India. Yeah, it does, Peace Lord. Have you used agent coding for Rust? Yes. Was it good? It was very good. It's very good now. Ted, good to have you here. Let's see. When did you start content creating and live streams? Well, that was about I started live streaming last August. So I've only been live streaming for about 8 months. And before that, I did some videos. Should the hackathon announcement also be in Blocks.ai Discord? Well, maybe. Well, we might, maybe. This is mostly for you guys. So this is a very special hackathon just for you guys. So we've got this hackathon here. It's mostly just for you guys. So if we announce it here in the Blocks.ai place, it'll be for other people. All right? And I wanted to do something special just for you guys. Just for you. I'm your old sub, Sandeep. Nice. Are you providing services for any company? Yes. Quite a few. Let's see here. PubNub. Go to the homepage. You can see quite a few of our companies here. Hey, want ad for this hackathon? I can create it. Hey, Ted, that sounds interesting. Send me a message on Discord. If we are building our own app for company, we will use PubNub. Hey, that's the way to do it. Ooh. Hey, Loons, thank you. I'll paste that to the pin board here. Let me pin your message. Pin. Here it is. All right, perfect. We got your message pinned now, Loons. DocuSign, Gcast, Scopely, Yelp, TalkShop, Swiggy is getting a job easy. I would say where you are, sir. I don't think it's currently easy. However, it is doable. It's doable, right? It is. It's doable. Are you a friend with Deb Kumar? I don't know. Hey, Quantified Quantum, good to see you. Welcome on in. Happy Sunday. Good to have you here. Let's see here. In India. I don't know. I don't know. Did you host the hackathon? Yes. We're hosting it now. Ready to go. It's getting started. We got some prizes. And very simple. Timeline ends on June 10th for the hackathon, you guys. And you just go to blocks.ai, construct your agent, make it public and functional, submit the blocks.ai agent URL and GitHub repo if you want to the hackathon channel. Then you're good to go. You're good to go then. All right. So let's see if we can continue onward here. All right, good. All right, we got it working. So now we got our optimizer. I want to say parameters would be LoRA layers. So we could do that. We can do 2 optimizers. Let's do this. Because you guys asked, we're going to do more than 1 optimizer, right? We're going to do more than 1. Let's see. Let me indent that. Okay. There we go. Multiple optimizers. Boom. Is it a group hackathon? Sandeep, you can do a group if you want. If you want, it's up to you. It's completely up to you. Stephen, basically, how's the project idea for hackathon providing code sandboxes to agents? I think that sounds pretty good to me. I think that sounds like a good one. How's this project idea for the hackathon? Providing sandbox to agents. I think that sounds pretty good. It needs to work with Blocks.ai because it's a Blocks.ai specific hackathon. However, it sounds like what you're describing is pretty close. It does. All right, let's get on with our fine tuning here. So we've got our sample prompt. I need to do the optimizer route now. So I've got the model. We can also do model.accelerator. Although I'm not going to do that right now because we don't need to yet. Let's see. All right, we don't need these things anymore. Let's get rid of that. Okay, we've got our inputs. Okay. Which company do work? Mandeep. If I use PubNub API, will I get extra marks, buddy? Yeah, you will. I would say so. Cool, cool. Yeah, you get a little bit of extra marks there. In Hackathon. Uh-huh. Yep. I mean, you'll sway the judgment. Just a little bit. All right, so which company? This is PubNub, you guys. That's the answer. Easy. How many layers did you unfreeze? I froze all the layers. So I don't know if I'm pretty sure. So here's all the layers are frozen. So freeze all layers in the LLM, right? Freeze all the layers. And then, oh, my alarm's going off. My broccoli timer is going off. All right, I gotta go get that real quick, you guys. I'll get my broccoli timer real quick. All right. Give me 1 second. I'm gonna get my broccoli and I'll be right back and we'll continue with our low rank adaptation fine tuning with a large language model. So I've freezed every single layer, basically. All right, be right back. BRB. Okay, here we go. Now we're back. Let's continue on with our low rank adaptation fine tuning. Broccoli's out of the oven. And then let's get our next song going here. This one. Okay. All right. Excellent. Excellent. Here we go. So I only want to get the linear layers, or I'm only going to do the last layer just for fun. Let's see if we can reduce the loss. I'm so excited. Wouldn't it be great if we could? I think that'll be really neat. Okay. So we've got our optimizers here. We've got our model. And am I missing something? We need got the optimizer. We need the criterion. We need a loss. We need our loss function. Torch.nn.mse. Right? Is this Python? Hey, Mega Banks! Welcome on in. Good to see you. Happy Sunday. Yes, it is. We're doing Python with PyTorch. Why is every cloud company saying that my credit card is a temporary card? It was in Microsoft Azure. Now it's an IBM cloud. Really? Wait, Loons? I don't know. Had no idea about that. Let's see. What is the scaling factor for this? Scaling factor. All right. So it's pretty high if you're talking about the rank. Scale. We do need to add this. So rank divided by alpha, right? We need a scale. Where do we say that at here? There is a scaling factor that I need to apply, and I forgot where to put that. Does that go around here? Right around here. Times scale. Right, we gotta do our scale here. There we go, like that. I think that'll do the trick. I'm being rejected by everyone. Loons! Oh no! Are you going to code a model in libtorch? Hey, yeah, well, this is libtorch. And we're using Python as the wrapper. Yep, it's this libtorch right here. We're right there, top of the screen. You see it? Got ourselves a little bit of PyTorch right here. Right there, some libtorch. The fact that you know about libtorch tells me that you know a little bit more than just AI. Discord, yes, Discord. What about Discord? Let's see, Ted. What do you mean Discord? You just said the word Discord. I don't know why. Why'd you say it? Okay. So we froze the layers. We got the forward pass working. I grabbed data already. So what we're going to do is we're going to try to get the model to answer a math question. I think that would be easiest. So we'll say, what was the math question that I had? See if we can get it to answer. So I had the fine tuning. Here we go. All right, so we need to copy and paste these over to this. Here we go. Perfect. Okay. Hey, Oxno, good to see you. Welcome on in. Happy Sunday. I hope you're doing good over there. Do you have a good weekend so far? What's up? Good to have you here. Do you prefer PyTorch or TensorFlow? PyTorch. All right. Actually, you know what? Since you guys asked that, let's do a quick little poll. What do you prefer? You see, what do you, what you heart? Here we go. What you heart. All right. PyTorch. We go Keras TensorFlow. Or we could do, how about Jax, right? Is another one. And what about Burn? Right, Burn, Rust Burn. Okay. Let's see, what's your favorite machine learning, deep learning framework that you guys use? How's it going there? Junaid. All right, good to see you. Thanks for clicking the hi button. Well, working overtime during the weekend. Yikes. Oh, Oxno. Oh, no. Oh, no. That's terrible. Unless you want to. Can we do some meetups or conferences? Oh, Gokul. Maybe someday. That might be a thing. If we get big enough. How about this? If we get big enough on YouTube, then that sounds like a good plan. Right now, we're just ordinary. We're just an ordinary streamer. But maybe. You just want my free AI credits on IBM Watson. Oh, that sounds good. Loons, that would be nice. Okay, so we want the model to learn how to add a number. We want the answer to be this. So we've got the answer, and we're gonna teach the model how to do a little bit of addition, which might be a fool's errand, but we're gonna try anyway. We're gonna try it. What model can I use if I have an Intel HD 3000? Let's find out. Here. Intel HD 3000. Let's see, HD 3000 RAM. Memory. How much memory you got? You've got... Oh, what? Wait. Acts as an integrated GPU. Automatically uses 1.7 gig of your system memory. Okay. So... Can it use more system memory? GPU starts with a small fixed amount. Automatically pulls in up to a maximum of 1.7 gigabytes. So you can use the model I'm using right now. So that would be the Quinn 2.5 0.5 billion model. You should be able to do that one. Small models. Yep, exactly, Peace Lord, exactly. I mean, it pays the bills, so why not? This weekend is a holiday in Saudi, but I'm working overtime during it. Hey, hopefully you get paid for overtime. Hopefully you get the extra payments there. You have a lot of potential, dude. Hey, thank you, appreciate it. It's really inspiring to see you working. Oh, that's fantastic. That's really great feedback. I appreciate it. Thank you so much. All right. So let's see if we've got what we need here. Thank you for the hearts. Oh, I saw you click the heart button over there. Thank you. Do you review projects from viewers? Yes, absolutely. Although a lot of the projects that I've been reviewing have been AI generated, which is fine. Because it's the current modern approach to software engineering is AI generated things. However, you know what? It's fine. I'll do it anyway. Just to see what's going on. All right, did we need to... Here we go. Let's only indent this once here. Okay. There we go. You got a new subscriber. Oh, thank you. Very nice. That's actually a really good sign that you say good positive things. How do you know if the code is fully AI generated? There's some tried and true patterns. There's some patterns that show up. And sometimes it's difficult to tell. Sometimes it's difficult to tell. Look at the memes on Discord. All right. I use the Zoami. Wait, no. Ziamio models. I'm not sure what that is. It's really cheap compared to Claude. I mean, really cheap. Oh, really? I've never ever heard of those. Are you a dev? Yes, I am. I definitely count as a dev because I've been doing this for a long time, over 25 years. And currently CTO at PubNub is a company I started many years ago. I admit by example, I say when I vibe code my stuff, and vibe coding is perfectly fine and acceptable. It's actually kind of expected in 2026, right? 2026, vibe coding is anticipated. Very clear IBM, I totally understand the limits. What's a unit? 20 capacity unit hours. I have no idea. Build analytical models and neural networks trained with your own data to deploy for use in applications. Same, 10,000 API calls doesn't mean anything. Doesn't it per month? Add natural language inference. Okay. Yeah, I don't know. I don't know either. I've never used IBM beyond just trying their quantum processors. I tested out their quantum processors. It's a Chinese model? Oh, got it. Okay. From Xiaomi. From Xiaomi. Okay. Think for the hearts, you guys. Didn't know how to write it. You did? All right. Well, sounds good to me, Oxnall. AI generated code without good coding knowledge is a disaster. It ends up being bloated, doesn't it? Right? It does. It sure does. Can I connect with you on LinkedIn? Absolutely. Let me know when you connect, when you send the connection, because then I can go here and I can click the thing and you'll show up. So when you're ready and you've sent the connection request, I will accept. Let me know though when you're ready. Okay. All right. Got our hackathon. Blocks AI agent hackathon. Whoa, Ted, nice. Very nice. Good to see it, Ted. Hey, look at that. Xiaomi is how you say it. Okay. Xiaomi. Xiaomi. Send a connection request on LinkedIn. My name is Muhammad. All right. Let's find out. New window, LinkedIn. And I'm going to LinkedIn. Here we go. Then I will go to over here. Let me zoom out a bit. All right. Found you. All right. Here we go. Let me send you a message. Okay. Here we go. 1 second. I'm trying to find you. Let me see. I clicked on you. The same thing happened yesterday. So I clicked on you. We're now connected. We are connected now. However, let's see here. How do I find here? Maybe this one. Hey, there you are. All right. Hello. Thank you for connecting. Yeah. Thank you for connecting. All right. We're now connected. Me, like in the word myself. My? Oh. My. Xiaomi. Thank you. Yeah, you're welcome. Absolutely. I can connect with you on LinkedIn. And that's what we just did. Okay. Sounds good to me. Okay. Let's go back to our code, you guys. Where are we now? So I would like to optimize these guys here. And we need our loss. Is this a good loss? Is that how I do that? I think so. I forgot. Let me see here. Where's it good? So just do Python import torch. We say torch.nn.mse. Is that a thing? Nope. Okay. Maybe is it just MSE? Nope. Dot loss. Let's see here. Nope. Where's our loss at? In torch, in PyTorch. Let's see. Dir torch. Let's see. Question mark. Loss. Where's that at? Where is it at? Do we have any specific losses here? I don't see it. I forgot. Why is it not BCE? I am not familiar with BCE. I've never tried it. Should we try it? Torch.nn. Let's see if we can do dir here. Do we have anything that's loss-ish here? Oh, maybe we do. All right, so what about MSE? MSE loss. There we go. Okay. I had it right the first time. Here we go. So that should do it right there. Let's validate. So I'm going to grab this here. And there we go. We got our MSE loss. So torch.bec is a binary cross entropy. Oh, well, you know what? We might need a different kind of loss. So I do have a reference here for what kind of loss we need to use for the LoRA fine tuning. Let's take a look at that really quick. So let me see right here. I'll just grep it. So we'll do grep for the loss. Let's see. Yes, for the loss in where was it? Reference. There we go. All right. What was it called? Loss. Where is it defined? Loss equals outputs.loss. No. Is that already going to be there? Okay, hold on a second. Let's do grep outputs. So basically, let's see, outputs equals. Oh, all right. Well, the loss is built in. I don't know what kind of loss it is, but we're going to find out. We're going to find out what kind of loss it is. All right. So we'll close that for now. Steven, which AI app would you recommend for financial applications? I do not know. I've never used one for financial applications other than building my own model for specifically day trading, high frequency trading. And we did that live on stream, I believe, early this year. So otherwise, probably, it seems like OpenAI has been optimizing for that. So ChatGPT with Codex might be the option, though that's the only recommendation I have for that because I do not know. So let me get you straight. Are you fine-tuning a model with data? Kinda you push the new data for it to learn? Yes, you guessed it correctly, Oxno. Yep, 100%. You got it. What do you use for the auto subtitles keyboard overlay? Oh, right. Yeah, okay, so we got a live keyboard here, right? And you can see when I press a button on the keyboard, it presses. Let's see if you can see that. Right there. Yep. You can see when I'm pressing on the keyboard there. And this is from a really simple plugin right here. It's not a plugin, actually. It's just the accessibility keyboard in Mac. That's all that is. That's all that is. It's really simple. Nothing complex there. And for the subtitles, it's my own software that I wrote 8 years ago. Right here on GitHub, I pasted a link into our Discord under link share. If you are interested, it's for free, completely for free. Not a little bit free, but 100% perfectly forever free. Hey, you guys. LLMs use BCE loss. MSE is for numerical differences. Okay. Nitsuwa, thank you. All right, so we're going to use BCE. One of the iconic machine learning engineers of the era AI. Thank you, at least for me. Find your videos inspiring, especially at my 38. Hey, Ben Cater. We are a similar age. We're a similar age. I'm in my 40s though, so I'm older. I'm older than you guys. What kind of data though? Oh, the data that I'm going to be using here is by fine tuning. Here, it's really simple. We're going to train the AI how to calculate a math problem. I think this one currently does not know how to do it. We're going to confirm that it doesn't, and then we're going to teach it how to make these two numbers that are very big numbers, and we're going to add them together. That's the plan. I just sent you the connection on Recast. All right, so let's go take a look, you guys. All right, so new LinkedIn. All right, I'm going to go over to the window here. All right, I found you. All right, let me click accept. Here we go. All right, we're connected now. I'll send you a message. Hi, Junaid. Thank you for connecting. All right. Wait. Well, I didn't spell it properly, but you know what I'm saying. Okay. We are now connected. There we go. Assume you need a lot of data. Oh, good news is, we don't. It's fine tuning. You need a smidgen of data. Just a little smidgen of data. You don't need to you do not. Hey, you're welcome. Junaid, you are welcome. Usually Hugging Face models come out with the loss, so you're good to go. That is actually one of the good things here. Yeah, so when I get the output from the model, when I do the forward, so we're going to inputs, we go to outputs here. So our outputs, we should be able to get our loss equals outputs.loss. So we've got that. So let's see if that works. Print loss. And this is going to be the loss function. So let's see if this works. All right, Python model. No, LoRA. All right, parameters. Oh, we didn't specify those yet. Okay. Here we go. All right. Let's see if that works. Assuming you need a lot of data. What were the results from your day trading and high frequency models? Mark Lemon. Oh, yes. Yeah, okay, we got to fix that. That's not a problem. They actually came out pretty good. We got 85% accuracy, which is enough to make trades for profit, right? So you need to have better than 50% as best as you can, right? Because if you make trades and you're wrong more than 50% of the time, you lose money. But if you're right above 50% of the time, you should be able to gain money overall, over average, right? So we got 85%, which I thought was pretty good. Oh, dot parameters, thank you. Hey, Needswa, thank you. Parameters, I forgot about that. All right, there. Good eye, you got a good eye there. Nope, yep, there we go. Okay, one second. Let's actually get this going here. All right, paste, delete that. Good, okay, now we're good. All right, let's see if that works. Thank you so much, appreciate it. All right, so far so good. Let's see if that works. Oh wait, another problem. All right, so it was a muon, got unexpected keyword argument parameters. All right, how about we just do Atom W? See if that does it. And that's how you spell parameters. Parameters. Oh, wait. We don't use the word parameter. It's just expected as the first argument, right? There we go. Hey, Zeus! Thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We're currently building a low rank adaptation fine-tuning with a Quinn 2.5 model. We're going to fine-tune a large language model is what we're currently doing. Oh, it doesn't have the loss. Tensor object has no attribute loss. Did you mean less? No, I didn't mean less. I meant loss. Well, gotta leave for your shift. All right, Oxnell starts at 4 a.m. Wow, that's really late. Need to sleep. All right, good luck. Tight. Eminem. We're making our way, right? We're making our way. This is great, you guys. This is great. All right, did I miss any of your messages? If I miss any messages, let me know. Let's see. Mark Lemon sent you the request. Ben Cater. Oh, yep, we got you. Okay, cool. All right. Hey, Steven, what's your streaming schedule? Daily. We go live daily around 10 a.m. to 12 p.m. Pacific Daylight Time. So I'm in the United States, and I'm in Seattle, Washington, so I stream from 10 a.m. to 12 p.m. Monitor and keyboard cam. Eminem, yep. I was thinking of doing that. So you got your keyboard here so you can see. What I was going to do, instead, I have a keyboard here on screen. So I've got an on-screen keyboard. So you can see what I'm typing. And it is a lot easier to see. I'm not going to do a monitor because it'll expose secrets, right? If I did a monitor cam, you don't use a mechanical keyboard. No, I just use a regular, well, it's a Mac keyboard. It's just a Mac keyboard with a number keypad. Yeah, it's a big Mac keyboard with a number keypad. Can you get another camera and point it at the monitor instead of streaming? No. Well, I mean, technically, yes, I could, but I have extra stuff on my screen, and I don't want you to see it. Because sometimes I gotta do extra stuff that's hidden in secret. All right, so model generate. Interesting. All right, so I'm not getting the loss here. However, I'm pretty sure we could use BCE loss, like you were saying. Let's try this. Do BCE. Let's try that. We'll just try BCE. It might do the trick. You don't know. You'll never know. Maybe print the output. Oh, yeah. Okay. Let's see what the output is. See what we got. Let's see what we got. Here, I'll do it below. There we go. So it's easier to see. Perfect. Look at general. You put the way you're supposed to say Xiaomi. Okay. It looks like it's just a tensor. Oh, it's a tensor with all the tokens. It's just the tensor with tokens. So that's really easy. That's it. It's just a tensor with tokens. Xiaomi in Chinese is Xiaomi. All right. All right. Is this sorcery? Hey, how's it going there, Beast Hunt? Wait. Max. Beast Huntery Max. Wait. Beast Huntery T Max. I was wrong by one letter. What's the shape of the output? It should be. It's just like one. It's a sentence, right? So it's a bunch of tokens. So you see, it's 2 dimensions, right? So I'll do the shape. That shape. It should be like 1 by a bunch. I don't know, 40. Maybe it's 1 by 40 shape. There you go. All right, it'll run again here. All right, while that runs, I'm going to check Discord really quick. You said general. Here we go. Xiaomi. 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 The subtitles are getting it. The subtitles are getting it. Xiaomi. Ah, look at that. That's great. Loons, thank you. Xiaomi. All right. That's awesome. Loons, that was great. All right, so it's 1 by 115. All right, so that's basically 115 tokens is what you're seeing here. All right, let's see what the output is. To add these 2 numbers, we need to align the numbers by their place values, and so I need to do more than 115. Is there like a limit that I'm currently setting on our output size? Let's see, message, generate, token, return, max new tokens, here we go. So let's do 400. Let's try that. Your subtitles are smart. Yeah, they are. They're pretty good. Xiaomi. All right, let's see what we get. Let's see. So it should be able to try to solve this, and I'm wondering if it's already going to do this. Let's see, how far did it get? Did it do it? It didn't get the correct answer. So that's good news. That's good news. What we'll be able to do is train the model on our new output. So let's see. I'm going to try to do one step on this. So how do we do this? Output dot backward. Or wait. No, we need our parameters, which we have our lazy parameters. How do we do this? So right, output dot backward to generate the gradients, and then we need to zero the gradients. How do we do that? I forgot how to reset the gradients. But you need logits, right, for the fine-tuning output. Yeah, 3.5 Flash is rocking right now. Is it, Ted? Is it really good? I've been using it, and I think it's pretty fantastic. All right, Ted, you know what's going on. Needs what? Yep, we need the logits, right, for fine-tuning the output. So yes, so probably what we're gonna do is, instead of generate, let's see. So I do have a reference. I do optimizer for 0 grad. Optimizer. So we've got our optimizers here. What do you mean for 0? Yes, we need to 0 the grad, right? We need to 0 the gradient. So that would be LoRA layers dot 0 grad. There we go, right? Let's see if we can do one step. Let's see if we can do one step here. Okay. Let's see if that works. Gotta go, bye. All right, Ted, thank you for stopping on in. Good to have you here. Enjoy the rest of your weekend. Let's see, that shouldn't crash, I don't think. Oh, and it did. It straight up crashed. Variable execution engine calls the C++ engine to run backward. Element 0 of tensor does not require grad. Oh, it does not. All right, okay. How do we do that then? We need to get it on the output, so. Oh no, you need to 0 the grad on the optimizer, not in the layer. Oh, really? Let's see. Okay, so optimizers. So where's he? For optim in optimizers. Go optim.0 grad. Like that. Okay, let's try that. Okay, let's see if that worked. You backward the loss. Oh, right, okay. So we take the loss and then backward the loss. Got it. Yes, I forgot. It's only been like a week. It's only been a week. Okay. Thank you so much. Okay, so we've got our outputs, and then we need to calculate the loss equals our outputs. You know what? We've got a reference here. So let's open up the reference really quick. Thank you. Thank you, NeedsY. Yep, you're getting it right. You're getting it right. Okay, by reference. So I've got a reference here that we are going to refer to. So wait here really quick. Let's see here. Optimizer. Yep, optimizer 0 grad. Outputs. We get the outputs. And then we've got why do we need to pass it labels? And then we get the... We might be... Okay, so, right, with the forward pass, it's going to be able... So this is the forward pass. This, and we get the loss automatically here. And then we backward the loss like you're saying. And then we optimize, we step on the optimizer. Okay. So input IDs. Let me make sure I get this correct. Oh, we clone. Oh, right. Okay, so it's identical. Okay. That's easy. That makes it easy. Do we still need the labels though? Let's see. Labels on the loss. Oh, because it automatically calculates the loss for us inside the model forward. Interesting. I've never seen that before. Hey, Neva, good to see you. Welcome on in. Happy Sunday. We get some experts in the chat, you guys, for some machine learning. We pass labels from the model, automatically measure the loss from predictions versus label. Yeah, I didn't know you could do that. I mean, it makes sense. I understand. I get it. I just never thought to do that. Steven generation doesn't really have good loss. You probably want to do a forward. So, wait, you probably want to do a forward. This is a forward right here, right? It's a forward right here. A little bit of forward right there. All right, so I'm going to grab this. Let's see, grab this real quick. And then we're going to paste it here. Okay, so instead of using generate, we're going to use this. We're going to try to see if that can work based on our current setup. Oh, reading the stuff above with the output model generate. Oh yeah, got it, yeah. Yeah, so I've got a reference down here from a LoRA example reference, right? A LoRA reference. And I'm trying to do as much as possible without referring to the reference because it's going to teach me, because the struggle is part of the learning process. Did you know IBM has a coding agent named Bob? Do they? No way. You put a link in link share? You should only use one optimizer. Hey, you know what? We could only use one optimizer. We can also use more than one. We could use more than one. We could also just use one. Let's see. All right, 1 second. All right, so is this going to work? Here, let me, let's bring this over. So CD, LoRa, CD, desktop, LoRa. Or fine tuning, maybe? Yeah, fine tuning. There it is. Okay. Let me say Python LoRa. Okay. Why more than one? Well, I've tried it before and it actually worked a little bit better. Because what I did was I created 4 optimizers in an array. So like right up here. Where is this at? Here. This time only doing 2. Previously I did 4 live on stream and I compared it to 1. Just using 1 only, and it performed better. It got better output. It's weird to run more than 1. I don't think I ever saw it for real. I used it for real, and it actually worked better. It's a really neat trick. Try using more than 1 optimizer at a time. You might be surprised. All right, Discord, you say? Thanks for clicking my link. Hey, all right. Link share, you said. Okay. Bob. Oh, it is Bob. Bob coins. Look at that. Counting system is in Bob coins. That's great. I love that. It's Bob, you guys. Welcome to IBM Bob, your AI-powered development partner. Hey, it's a coding agent. It's going to write all the code for you. Look at that. There it goes. Nice. I had no idea that Bob existed. I didn't know. Wasn't the optimizer? We'll try to rewrite the parameter each other. They optimize it through a step, right? So you can step over. You can do you can only do one per back pass, right? Because when you can consume the gradients per optimizer. So you need to shuffle them per sample, right? You can't use more than one optimizer per sample. So you do a training sample and then you randomly shuffle which optimizer to train the model on with that one sample. And then you shuffle it again and you have to go through another step. So you have to step each time. Just the name Bob makes me laugh. It's pretty good. It's pretty good. It's so much better than the other product names. I know, right? They're definitely got an idea on that. Okay. So input IDs, where is it at? Labels. All right, so input IDs. Do we need to do something different for those? Definitely grab this really quick. Tokenize outputs, input IDs. Okay, got it. Okay. Got it. Here we go. Okay. Copy. Here we go. Outputs. No, we need this here. There we go. Tokenized outputs. And is that this? Okay, let me double check. Why? Okay. Is this different? Paste. Here we go. All right. Does these look different? All right. That looks the same. That looks the same. Add generation. No, it's different. So message, add generation, prompt, true. Okay, so that's something different than we didn't have before. Otherwise, everything else is identical. Okay. Okay, there we go. Looks good to me. Okay. So let me see here. Let me double check. So you're going to different optimizers each step. Interesting. Yeah. You should try it. It actually works pretty well. It does. It works really well. We did it. We did it live on stream. You should be able to use 2+ for these sample. For the same sample, they don't destroy the gradient. No, they do though. I tried. You should be able to though. You really should. There might be a way to do it. I feel like there is. It shouldn't require consuming the gradient in order to optimize per step. You should be able to use all optimizers in a single step. I feel that's true. However, when I did it, I didn't know how to do it. I was only able to use one optimizer per sample. There might be a way. I feel like there is. I just never tried. I never figured it out. I did not figure it out. Okay. Okay. Return dictionary true. Okay. Looks good. PT, tokenizer, message. Okay. So we want these guys here. Add generation prompt. So the only thing that's different is this piece here is the... All right. So now are they identical? Yes. Okay. Okay, let's try that. Input IDs, labels, input IDs, clone. And then we're going to get the loss across that. So we can see what all the steps of the loss will be. Input IDs, labels. Okay. Let's see if that works. I think you mean IBM Watson? Not Bob. Oh, it doesn't know about Bob yet. It doesn't know. Inputs not defined. Did you mean input? Let's see here. I did. Oh, wait. Oh, I typed it wrong. Okay. We need to print outputs. Okay, input ID shape -1. All right. Let me figure out how to deal with this here. This is just going to print the actual output. All right. Tokenizer decode. All right, here we go. Let's see if we can grab that. Copy. Okay. That should do the trick, because now we got our generated tokens. We don't. Gathered output tokens, inputs. Oh, hey, it's right there. It's right there. Hold on. Special token, true. I have the same thing. I have the same thing already. So why is my code different? Why is my code different? Haven't heard of Bob. Yeah, it has not. Claude, it has not heard of Bob yet. It doesn't know. How's bad? Hey, bad Redden. Bad Redden. What are you saying over there? Do you know diffusion model? I know of diffusion model. I know you start with noise, and every time you pass through the model, it denoises it. So it's like a continuous denoising. How much of a good computer do I need to solve the problem of predicting accidents from atmosphere time of year? You don't need you need a regular computer. Your phone could do it. Your phone can do it. If I'm willing to do the training locally, your phone will do it. Because you don't even need a deep learning framework for it. You can just use scikit-learn. So I would do scikit-learn, Learn, for that type of training. Because it's just standard machine learning at that point. All right, where am I at here? Why is this not? Because this is generated token for here. Hey, thank you for the hearts. Appreciate it. Thank you so much. Where does your knowledge stops? 2024. It seems like I should maybe know. It might know. All right, so why? There we go. Just gonna understand why it's not. Here we go. So what is different? Why is mine different? Shape -1. It's right here. It's the same thing. These two things are the same. Right here, right? This and this. Let's see. Y based. Here we go. Outputs. Generated outputs. Let's see. Where is this at? Why is this? Oh, it's down here. Here we go. All right. Generated outputs. All right. I need to grab this. Oh, this is going to just... Okay, got it. Okay. Thank you for all the reactions, you guys. Appreciate it. So where is my output? Here we go. So we need a different output here. All right. You know what? I think we're fine. What we're going to do is we're just going to run it. We're going to ignore the printing. And then we'll see if we get it all correct at this point. All right, perfect. All right, outputs. Looks good to me. All right, now we should be able to run this and it won't crash. Right? No crashing. No crashing. There we go. That's what we're looking for. All right, making progress. So now I should be able to grab the loss, right? Let's try this. Loss equals outputs dot loss. We should be able to print that. Print loss. We'll call this a loss colon. All right, we'll try that. Let's see what we get. Let's see what we get. And it should be... Actually, I have no idea what it's going to be. Is it going to be an array of losses? No, it is. It's just a regular loss. Right there. All right, we're making progress. It is a negative log likelihood loss. That's what we're using right there. Look at that. Negative log likelihood loss. Right there, you guys. Right there. All right, we're making progress now. This is great. This is great. Okay. So we should be able to grab the item on that. We should be able to run backward on this. So loss.backward. And then we'll optimize and we'll do a optimizer.step. Let's try. Let's see if we can do the backward now. He's first. Wait, who's first? Honestly, depends on if he's got coffee left. But knowing Steven, he'll probably grind through it midnight tonight. I might, maybe. Do you think Steven, the streamer, will finish today? Maybe. I don't know. I think we might need more than one. How much time do I have left? Well, we've got about 40 minutes, so we've got enough time. How long have you been learning PyTorch? For a couple months now. A couple months. So before I knew deep learning through my own handcrafted code, I understood how to handcraft code. I did this. I wrote my own GPU kernels, matmult, and fused kernels, including activations to calculate feed forward and the gradients with the derivatives. So I was able to create two fused kernels, one for feed forward and one for back propagation. And they're both fused kernels. Then I also built another deep learning model using PyTorch, NumPy, which is really easy. It makes it so much easier to use NumPy, although it wasn't hardware accelerated, right? So it was just specifically CPU bound. It was just CPU only. So that's my experience. What object relational model database solution do you use with Python? I mean, what is it? What's the best one? Dribble? Right? No. What is it? Django. Django. Django's the one. Django's the answer, you guys. GPU crawling must be hard? Yes, it was. Although it was really neat because you get to access the thread IDs based on what core you're currently operating your math on, because every single core gets the identical code. When you submit your compute shader to the GPU and it compiles, it'll compile and load on every core. Every single core. So say you have like 1,000 cores or whatever. Then when you're performing your math in your equations, you need to refer to what cell is currently running. And you get the opportunity to do this with an XYZ thread. And it allows you to do 3D matrix multiplications, which is why you've got your input layers, which are 2D, and then you've got your batch, which is going to be an extra dimension. So you've got your X, Y, and Z. There you go. All right, there you go. Fully utilizing the entire GPU. DC meme. Wait, what DC meme? GPUs usually simpler problems, so it's much easier than you would think. Yeah, it feels weird at first. It does, because it's a little weird. Django is a web framework. It's also an ORM, right? It's got a little bit of ORM in there too, right? Django include ORM? I think so. I think it does. Wait, let's see here. Watch this. Django include ORM, question mark. Yes. Yes, Django includes a powerful object relational mapping by layer default. Check that out. I think it's got a good one. I like it because it's got a whole bunch of templating and really great ways to create views, so you can do an MVC. It's nice. Low level language. You got it. YouTube API's got some problems. Oh, you got 500 errors. Oh no. What's an ORM? Explain. Yes. Typically, interacting with your current language and a database allows you to abstract away the SQL. You don't need to use SQL. You can use simple create, read, write, update, right? Create, read, write, update. ORM is like a translator that lets you talk to the database in normal code instead of weird SQL. Hey, here we go. So you prefer Mac over PC? Yes. Uname Darwin right there, which is a Mac. ORM is the way to go. Not write SQL because you're scared of SQL. Well, you know what? I've since switched myself. I've switched when I'm writing any web framework and I'm interacting with the database. I just use SQL directly now. And I don't want any overhead. So I try to keep my libraries to a minimum. Minimum! I keep everything to a minimum. You're scared of SQL? No, don't be scared of SQL. It's amazing. It's a wonderful domain-specific language. It's so good. It's great, you guys. Django or Fast API? Well, Fast API for sure. However, Django isn't going to include everything. I use Fast API because it's just the web server part. And you can use it with Gunicorn, which is a runtime that allows you to fork and do multi-processing, which is fantastic for AI models that you're running inside containers. Because it makes it so you only have to load the model one time, and you can split it and have it run in parallel across multiple cores. Did you know you can do that? That's how you do it. Otherwise, if you're running a really big model, you have to load it up every time, like these hundreds of megabytes. You have to load it from disk. Just load it from disk once. There's a much better way. Thank you for all the hundreds, you guys. SQL can go read. Yeah. Oh, this does that. And it's much easier to ask people and LLMs what stuff does. It is, yeah. You're scared of ORMs because it's more complex. Yeah. ORMs like to hide all the stuff they're doing. How would you use SQL directly? You typically, so in Python, you can get a sort of, they're called like drivers or just libraries that'll allow you to create a TCP connection to the database and then communicate with the database using the database protocol. And then you pass in SQL along with it. It's actually that simple. It's actually not that complicated. So I just use a library. Or if you wanted to do your own direct TCP connection, you could do that too. You just need to know what the commands are for submitting work to the database. Have you used Nest.js? I have a long time ago. Not recently though. Best TypeScript backend for you. Oh, is it? It's a really good one? Nice. You'd need to know async in order not to block the server thread. Yes, definitely use async. Yep, you know it, you know it. Yep, you know it. Personally, I find SQL much easier than ORM. Me too, because you need to know SQL is portable, right? SQL will work on all the languages, the same. However, if you need to use an ORM, you have to learn the ORM for the specific language that you're using. And so it's not portable. Right, it's not portable. You need to know async much as the ORM does. You can use SQL either sync or async. Yep. You sure can. You sure can. All right. Where are we at here? Where do we get? So let's see if we can do a backward pass. Here we go. Python LoRA. Is it going to work? Are we going to generate our gradients? Yeah, there we go. We generated the gradients. Okay. So now we need to step on the optimizer. Let's do this. Let's optimize. We'll do one optimizer. We'll do the first one. See if this works. All right. Then we are going to optimize dot step. There we go. Okay. And then let's see if that doesn't crash now. Wait. 0. There we go. Set no paste. Okay. All right. There we go. Let's see if this works. I think it will because we've already got the backward. The optimizer should work. We did it. Now we just got to do it in a loop. All we got to do is do it in the loop now. Let's do it in a loop. All right. Let's see if we can get some loss. Oh, this would be so great if I was able to do this just today. Okay. So this needs to go in a loop here. So we keep messages up there. That's fine. Optimizers looks good. Okay. So for epoch in range. I don't know. It's not really epoch. We'll just say sample. For sample in range 100. We got to indent all these things so that they're inside. Here we go. Okay. Input features labels. Outputs. Looks good. Okay. Loss optimizers step go. All right. Let me just print the loss. There we go. Perfect. Okay. Good. Gotta go. All right. Look at memes. All right. We'll check out the memes real quick. Your setup is very clean. I saw it on Discord. Hey, nice. Good to hear it. Hey, let's code, guys. Good to see you, Jeremy. Jeremy Evans. How's it going? Good to see you. Happy Sunday. Hope you're having a great weekend so far. We're just getting our low ranking adaptation fine tuning working here. And I think we kind of did it. Good to see you, Jeremy. All right. I want to go to Discord really quick. You said memes? Thank you for the reactions, you guys. Oh, hey, we got some memes on here, you guys. You guys got busy. What are you doing? Front end, back end. Yep, yep. Because this is the back. Yeah, exactly. This is scary. It's scary. Also, yeah, 3D rendering. What's your next AI model after LoRA? I don't know. I think I want to do a transformer and train a transformer from scratch. I probably just want to simply use the PyTorch transformer library. Just a simple transformer using PyTorch. Then after that, I might jump into writing my own transformer from scratch. Probably still using PyTorch, just writing the math myself. So that's the plan going forward. When the table is not required anymore. SQL programmers, table, yep, truncate. You could truncate or drop tables. This is drop tables. This is drop. Yep, you're dropping the table. I get it. I figured it out. Drop the tables. Java programmers, C++ programmers, Python programmers. Yeah, running on a Roomba. Yep, because it's automatic. You don't have to do any of the Yep, it's all automatic. Transformer, fairly straightforward. It's like 3 layers. There we go. That's key. Yeah, there we go. Neva, you got it. Good ideas. Just let me know if you need help reference. Yes, I do all the time. Backseat, 100% welcome because I'm learning. I'm learning these things. I want to learn as much as possible. The big complex thing is softmax, QKV. I actually did that part. I've written that myself. I did the complicated part, yes. So that is the self-attention. The softmax times Q and K, query and key, transposed, right? That's the transposed. And then you multiply the value after the softmax. That's actually pretty straightforward. Is that the... You say big complex, but I say simple complex, right? I said simple. You built data engineering project with AI, simple, pull real-time data from API, uses Kafka, producer, and broker, store data in Postgres, and run model with prediction. Finally, using Streamlit for business intelligence. Jeremy, that sounds fantastic. That sounds fantastic. You should learn mixture of experts. Oh yeah, all right, I'd like to learn mixture of experts as well. You love coding on weekends? Well, that's what we're doing too. We're doing it too. Everyone else is like child's play, literally just linear layer and linear norm. A layer norm, that's all you gotta do. Think for the hearts, you guys. Good to have you here. It's great to have you here. Okay, was there another meme? Okay, we got one more. We got a couple more here. When you switch from C++ to Python, thanks guys. It's so long, partner. Pointers, incrementers, end of line statements, brackets, and the main. There's still main. Main is still there. This isn't gone. You can still do main. You don't have to, but you could. It's still there. I like that. Oh, mixture is kind of tricky, especially at inference. That annoying bit is to make efficiency, so you need custom kernel. Oh, we need a custom kernel there. Malloc will be missed, right? Yeah, exactly. Malloc, that counts, right? Malloc, that's a good one. That's a good one. If name equals main, there you go. See, Jeremy knows. Jeremy knows. You know it, Jeremy. Programming with Python. Yeah, hey, programming with C++. Directly programming in binary. Oh yeah, machine code. Straight to machine code. Giga Chad. Got the Giga Chad there. SQL. Yep. There you go. Dragons. There be dragons. Representation of SQL. Is it really? It's fire. It's a fire. Greetings, Steven. Hey, Squirrel Sniper. Good to see you. Happy Sunday. Welcome on back. We're continuing with our low rank adaptation fine tuning. That's what we're doing today. And we even trained it on one sample. One step. We did. We trained it. Hey, The Last Attack. Welcome on in. Good to see you. Happy Sunday as well. Hey, bro. How's it going? We're going good. We're continuing our low rank adaptation fine tuning on a large language model. And we did one forward pass. We did one. We got the optimizer working. All right. So for optimizer 0 grad. All right. And then I need to randomize if I wanted to. We could randomize. Maybe we should do, let's see. Let's do this real quick. Python import random dot random. How can we do rand int? Is rand int a thing? Maybe it's random. Nope. How do we do random int? Rand int. There we go. We do 0, 1. Can we get 0 to 1? Yep. Okay. So then I can say the length minus 1. What if we did just 1? No, it requires. Okay. So it's going to be 0 between 1. Okay. So we will grab this code here, paste it, and we are going to say our optim is going to equal one of our optimizers. And then we're going to 0 grad it. There we go. Optimizers random. And it's got to be len minus 1. Minus 1. There we go. This gives us the index for our optimizer. There we go. Okay, optimizer, 0 grad. And then we need to update this layer here to Optim. There we go. Perfect, perfect. Are you using LoRA? Yeah, I am. We are using LoRA. You got it. All right, bro, Rust is good. Yes, it is. It's very good. It is. It's great. I use a lot of it. I use Rust everywhere. In my company, you guys, PubNub, we use Rust for extreme latency amazement. It's so good. It's so good. We are in microseconds. We have exceeded the world and entered into microseconds. No longer milliseconds. It's now microseconds. It's a whole new world. When I first started this thing, it was milliseconds is the thing that you want to target. And now it is microseconds. Not much job. Good for personal project with need system programming. For Rust? Oh, at least at my company, we're all Rust. I mean like 90% Rust at this point. Is your video post in automatically generated? Yes. Yes. Yes, indeed. Okay. I want to go to my code here. All right, I think we've got our optimizer randomly selected per sample. Then I zero the gradient, get the loss, automatically calculated for us by the really nice Tasty. It's just so good. Automatically gets it for us. We do a backward and then we optimize with the current optimizer. The only thing is I don't know if the muon is gonna work here because it may or may not work with negative likelihood loss. So the problem with muon is that this right here may not work with NLL. It does not work with negative log likelihood loss, the muon. So I think we might need to change that. All right, let's see if it works, you guys. Let's see if it works. Is it gonna work or is it gonna fail? Yeah, wait, oh, I forgot to import random. Whoops. Here we go. Little bit of a mistake there. Just try one optimizer simpler. Well, you know what? Hey, look at that! Hey, look at that, Neva! Hey, look at what's happening right now. We're fine-tuning with LoRA. Oh, look, the loss is dropping. I think we just did it, you guys. I think we just did it. Hey, look at that. Oh, that makes me so happy. Hey, Neva, we did it with even the muon, too. Isn't that great? Oh, it's so cool. Multiple optimizers. I told you it would work. You can see right there. It worked. Thank you for the party poppers. Oh, I feel so good. I usually like Rust 3 to 4 times. Your operating system, scheduler, and file system. Thank you for the party poppers, you guys. I also use it for creating command line interfaces for your personal project, which you sold to a client. Jeremy, that is fantastic. That is fantastic. Let's see what generation this model does after fine-tuning. Yeah, I'm actually kind of curious about it too, right? We're going to fine-tune this. So we got to do a few extra steps, right? So we can continue running it forward. We don't need to do the optimization yet, right? So we got the data. So all layers, we'll just do that for now. We optimized the model. This is happening right now. I'm going to add an extra one in here. So you use multiple optimizers. We did that one right there. Then we need to use Neva's optimization trick where we simply merge the weights directly into we add the weights directly into the existing model and mutate the model. We're not going to do that right now. We're just going to feed forward. We're going to just see what it looks like. We're going to try it out. Oh, what's your favorite programming language? Rust. I would say Rust, followed by easily, I've got top 3 languages. Rust, Python, JavaScript, and C. So there's 4 languages. These are my favorite. C, JavaScript, or TypeScript, Python, and Rust. Those are my favorite. It's Python for you, and very nice. Yeah, I use Python for all artificial intelligence stuff. And if we need to go super big, then we'll use C++. For now, though, we might decide. Before C++, I would hit Rust. HTML, there you go! Right? Hypertext markup language. Let's see the generation. Yeah, we're going to do that. Are you familiar? Golang, yes! Yes, I'm actually pretty familiar with Golang. I like Golang channels. I think that's a really clever trick. I like how Golang has all the necessary libraries automatically available for you in the standard. When you download Go, the compiler comes with standard libraries that are perfect for microservices, building web apps, right? Essentially the backend for the web app. It's great for that. And it compiles to a binary, which means it can be very small, fast, and efficient, running in a from scratch Docker container. It's great. It's great. I love it. It's wonderful. However, you can also do that with Rust, and you can get better performance in Rust. So that's why I switched to Rust. Can't spell Goat without Go. All right, greatest of all time, Golang, used for CI/CD. Oh yes, we do too. Yes, we do too at PubNub. PubNub. Let me spell that correctly. We use concourse plus Golang for CI/CD. We do. Are you using Arc? A lot of Rust Go would be faster. I do use Arc for automatic reference counting. I do. If you're using Arc, a lot in your Rust Go would be faster. Oh, I'm not using a lot of Arc though. I'm using some Arc. Go had way better GC than Arc. Oh, all right. Yeah, I mostly use stack-based memory in Rust as much as possible, and only a few clones. That's it, just a few clones. Only where it's not necessary. Okay. So let's try a feed forward and see what let's test the model. So we train the model. All right, so train on 100 samples. And then let's see here. Calculate the sum. We need to, wait. Hold on. I need to train it a little bit better. This isn't correct. I need to grab different data here. Yes, Steven, you're a pro. If you take the average dev, they would probably write faster Go than Rust. Oh, got it. Okay. That makes sense. Go is more accessible for writing pretty fast compiled language for any developer. Understood. With Rust, you have to know a few things to make it fast. Why Rust? Cargy exceeds 20 gigabytes. Oh, which crates are you downloading? That's a lot. 20 gigabytes is huge. Rust Tokyo is good. You love async code. Hey, Jeremy, yes. I love it too. Tokyo is fantastic. I like Tokyo. Okay, let me go back to some of our code here. Where did we leave off? I want to run a forward on it, though I also want to train it on the correct data. So let me grab the first message. All right, so this is the test message. This is a test message. And we're going to get our other messages here. Let's go by, where is it? Fine-tuning JSON. Okay. Here we go. Let's grab these guys. Just these here. Okay. Copy. And then we're going to replace this one here. Here we go. This will be the full message. This is a training message. Set paste. All right. Full message for training. Training message. And then we're going to have our test message up here. Although, you know what? We could just do a slice. Training message and testing message. We don't need to repeat it. We'll just use a slice. All right, so we'll just say test message afterward here. Test message equals a slice of message. A message with a slice of the first two, 0:1. I think that should be fine. 0:1. So it should be the first and second. Print test message. Let's see, what do you guys think here? Let's see. I knew Rust from Cloudflare. Oh, Pingora! Yes! Yes. A tech everybody uses without realizing. You do. A large amount of the internet is run on Rust now with Cloudflare Pingora. Interesting. Can't wait for the output. Me too. We're going to find it. We're going to see what it looks like here. So this is our test data. I think that's enough. Let me double check here. Let me see here. Python. Let me say 1.23. And then I want 0:1. Okay, so 0:2. That's what we want. Okay. Increment. There we go. So we don't need to print that anymore. All right, so now we've got our test and our training. Let me go get our generator really quick, where I have that over here on GitHub. I believe, is that here? Yes, okay, perfect. So let's grab this really quick, and we're gonna do a quick test here. All right, so def test. Let's see here. Set paste, set no paste. Do some pretty indentations there. And then we're gonna print our output. Okay, I think we did it. We should run our test method as well. Test. Okay. And where else? Oh, so we just finished training. So we're training and we're testing. Testing. All right, I think we're good to go. I think we got it, you guys. I think we got it. What did I miss? Hey, Loons! We successfully got a good outcome, right? We got our target loss was reduced, and we did it with LoRA fine-tuning. And I was able to do that. We got it working. There's also so much C++ you're using. Like if you're using Windows, you're using C++. That's right, Neva. C++ will never die. It's going to be around for pretty much at least the next 100 years, if not more. Right? Well, you know what? It's possible that the AI will be able to rewrite everything that's better if the AI gets good enough. Probably need a few years before that happens, right? The AI might just choose to use C++ though. And so that will like extend C++ life. Include IOStream. Oh yes, int. We got our C++ here. Jeremy, you're saying something with 42 standard. Are you sending data to std out and then kind of esoteric, but it works? What are you printing to std out there? I'm trying to read it. It's like all on one line. It's all like hard to read. Which Rust library for building API? Actix is old, and it's been, you either want to use Axum or something else. So Actix has been around for a long time. The ergonomics of Actix is not it's a bit much. I would say Actix is overwhelming. You want to use something that's a library that's going to make your life easier and happier. Axum is the answer. Did you see Zero from Vercel? Oh, the new programming language. Yeah. It looked like it didn't make sense. Like, why did they do that? Why did they do that, you guys? It didn't make sense. There's no benefit or value to it because large language models already know C++ and, Lua, JavaScript, Java, whatever. They just already knows those languages. And so creating a new language that an LLM doesn't understand doesn't make sense. Axum is with Tokyo Async is amazing. There you go, Jeremy. Exactly. All right, so let's see if we got everything we needed here. Where are we at? Where are we at here? All right. Axum with Tokyo. All right. Close this. Let's see if we did it. Let's see if we did it, you guys. Test message. Oh, we forgot to do test message. All right, I did it wrong. Let's see, test message. Oh, messages. Here we go, yeah. Messages, plural. And then we need to use test message down here at the bottom. Inputs, test. Here we go. Much better. All right, let's see if it works. Do you know quantum assembly exists? It's Quasm. Well, it may, okay, so probably yes, because you're programming a chip that specifically is a quantum processor. So you could have just used the standard .s, right? There's no need for a Quasm. However, it's perfectly fine that they did that because it's actually kind of neat. I think it's kind of neat. Not required, not necessary, but it is neat. You could probably get better results by taking an existing language like Rust and changing the printouts for errors. Right? Exactly. You don't need to rewrite a whole language. specifically built for large language models, you don't need to do it. You can just maybe slightly modify an existing one, right? I think that seems like a good idea. All right, let's see if what we did works here, you guys. Let's try it out. Let's see what we got. Did we do it? Did we do it? I'll be very happy. All right, there it goes. It's starting to learn. It's learning. I might want to put this on an MPS. Let's see. Let me put this on my hardware. Currently, it's running on CPU. Hey, it dropped below 1. Hey, there it goes. Oh, wait, hold on. It's going pretty slow. I want to see if I can make it go faster on my accelerator. Let's see. Model. Let's see. Model that device. Should I do this here? I think so. The only thing is I don't know if they're all on this. To get them on the right device, I need to put them all in the same. So how about this? How do we do this? All right. Because these parameters here would also need to match the device, right? So device equals model.device. And then we say .to device. There we go. All right, that should do that. I think. I'm pretty sure. And then we need to, let's just try that. Let's see. I think that should be work. Model dot equals model dot to accelerator. All right. Do you know about the Lympha crate in Rust? I don't know about it. I've never heard about it. Most of my valuable assets as my GitHub account. Do you agree? That is a really good credential. Your GitHub account is a fantastic credential. If you are a software engineer and you want to demonstrate your capabilities, a really good way is your GitHub repository. All of them. Not just one, but your entire profile. What is Torch Accelerator? Oh, this is your current accelerator. I really like this. It is new to PyTorch 2, I believe, which automatically selects the best accelerator. My accelerator is MPS, Metal, on a Mac. Best accelerator. All right, let's see if that works. I might get a device mismatch. Let's see. I tried really hard. Oh, there it goes. But it's not learning anymore. Oh, that's a problem. It's faster, but it didn't learn. All right, it didn't learn. It's faster, but it didn't learn. Add these numbers. All right, so did I say 40? I need more than 40. Let's do like let's do 100. Let's do 200. Hey, Ashish, good to see you, Ashish. Welcome on in. Hi, bro, Low from Pakistan. Good to have you here. Happy Sunday. Hope you had a great weekend so far. Lympha is the scikit-learn equivalent for Rust. Oh, really? That's really neat. Okay. So Lympha, let me type this in so I remember it a little better. So Lympha equals scikit-learn for Rust. All right. What's up? What are you doing? Igor, welcome on in. Happy Sunday. Good to have you here. We are currently building a LoRA fine-tuning is what we're building. It is a low rank adaptation fine-tuning for a large language model. And we got it to work. The only problem is immediately when I converted over to my device accelerator, it stopped learning. So we've got a problem. We need to figure out how to get it to learn on the device. So maybe we've got a problem here. So we're gonna model the model that to device. So bring the model accelerator there. And we've got our LoRA layers. And then we set the to device. The only thing is, it's just not working anymore, and I don't understand why. Hey, Fiber Brian, hello, you're back. Welcome on back. Good to have you here. You have a project in your course. Your AI decided to make an automated program grader for my computer science facility faculty. Is it a good project? That sounds like a good project. Because it's necessary. Wouldn't you be great to get automatically graded on your work? And the AI does the work, yeah? Shouldn't matter what device you are on, like either it crashes or it doesn't. Yeah, so what's the problem, right? Exactly, Neva. Chilling on the sofa, watching Steven. Jeremy, that's good to see. Thank you so much. I think GPU drivers are not optimized. Yeah, well, yeah. If doing it at 2 devices changes the behavior, that's a bug. Report automatically. We should report it. Yeah, exactly. Because it's working. It's just not learning after that. And it could have been something I did that's causing that to happen. So what I'm going to do really quick is I'm going to hide this. And I'm going to try it again. See if that does the trick. Maybe I did something wrong. Right? I might have done something wrong. So let's find out. Here we go. No, I didn't do anything wrong. I didn't. It's certainly slow, but it's fine. Which language is that? That's Python, Fiber Brown. You got it. Jeremy, thank you. Sometimes PyTorch has bugs around sync, especially for newer backends like Metal. Oh, okay. Gotcha. What's your AI's name? It's just a low rank fine tuning with a large language model. That's what. Low Rank Adaptation, LoRA. It's not my model. I'm using Quinn. However, we did successfully write our own LoRA right here. We wrote it right there. We did it ourselves, you guys. What you usually do after live ends? I need to finish my weekend chores so that way I'm ready for the week. My weekend chores include typical like cleaning, laundry, and food prep. I do food prep because that means that it's a lot easier for me to work as much as I possibly can on the weekdays. Yeah. Quan. Yeah, we got the Quan. Xiaomi. Xiaomi. There we go. Change the how much RAM variant do you have? I have a lot of RAM. Here we go. I'll show you. H-top, real quick. There you go. Quite a bit of RAM right here, you guys. Right there. Little bit of RAM. Just a smidgen of RAM right there. Little bit of RAM. Can I join your company remotely, please? Yes. So you can see I'm currently running CPU. I want it to be GPU accelerated. However, I'm having issues with that currently. Do you work in a company or what? Yes, Fiberbrine. I do. I got my own company. All right, you guys. For those of you new here, thank you for joining in. Happy Sunday. We software engineer on this channel, code by hand. We're currently focusing on AI, learning PyTorch and various AI approaches. My name is Stephen Blum. I'm the CTO at PubNub. We are a communications company that adds in-app communication to your app. This allows you to add chat, multi-user experiences like multiplayer, collaboration, food delivery, on-demand order updates, score updates, a whole bunch of things. Anything that you need when you communicate between your device. We raised $134 million at our Series E, 1 billion devices on my network today, 68 patent claims granted. Which one is that software? Nice. Yeah, it's good. OMG. Dude, that's so, yes, I've got my own company. That's just Linux process viewer fiber. Yes. This is Linux. This is HTOP. PubNub sounds cool. It is. It's really cool. How are the live captions so fast and accurate? I know, right? Mink, it's great, isn't it? I wrote this myself. This is software I wrote 8 years ago. So see, find 8 years ago. There we go. 8 years ago, you guys, right here. This is software I wrote. It is subtitles for your stream, your live stream. Are you on YouTube? Are you on Twitch? Are you streaming? Maybe you're just doing a video conference call on Zoom or Teams, right? Microsoft Teams or Google Meet. You can use the subtitles there. Do you play games? I sure do. I've been playing Crimson Desert and Minecraft recently. That's what I've been playing. Give me the details so I can apply. We'll do free of cost, no money needed. Please tell me the process. Hey, so if you are interested, we do have some open roles. Go to careers. I will paste it into our link share. One moment. I need to. My alarm's going off. I gotta turn the off button here. Let's see. Turn off my alarm. Let's see. 1 second. Minecraft. Let's go. Right? Hey, there we go. Yeah, I like Minecraft. I've been doing some modded Minecraft recently. Better on Bedrock. Where is my alarms? Here we go. See, I've got my alarms here. You probably can't see it, but that's my alarms. Delete. Okay. There we go. Minecraft. I love redstoning. Oh, you like doing redstones? So have you created any like really great machines or anything like that? Anything with like observers? I've done some observers that like monitor the block in front of them, and I've done some redstones that replicate actions with pistons. Fiber. Wait, a Windows subsystem for Linux. WSL, you got it. So yeah, here, I'll paste this. So if you guys are curious in jobs at my company, I have some open roles for you. Go into link share. There you go. Paste it right there. You hate redstone, man, but I love building. Oh yeah, oh no, all good. Building is a way to go. That's one of the great things about Minecraft is it kind of inspires creativity, right? Hey Aditya, good to see you. I'm hoping for some positive response from the interviewer. I recently got interviewed, but I want to ask you, have you ever failed at an interview? How did you deal with it? Well, I did fail. I did. I interviewed for a startup here in Seattle many years ago, many decades. They were a startup online because it was web-based back then. They asked me some questions, some tech questions. I got all the tech questions right, except for I missed some common product knowledge. They asked me what product ownership meant to me. And I said, well, that means that you own the product. And that's definitely not what that means. I mean, it usually is run by a product manager. Product ownership will be creating a whole bunch of tasks for engineers, interacts with customers, gets feedback from customers, owns the product development lifecycle, adding new features, getting releases, working with marketing and sales for training. Like I missed it. I got it wrong. And because I got that one thing wrong, I probably got other things wrong to be in. I failed. I failed the interview. I said, hey, did I win? Did I win? And they're like, no, you didn't win. You didn't win. What are the processes and qualifications to join your company? We've got the answer for you here. You just click into it. So we've got a couple of options available for you. Here we go. So we give you all the qualifications, all the things that we're looking for. And, like built internal frameworks, API SDKs, tooling, team shipping features. Let's see, what else we got here? Integrating with LLM interfaces, evaluating, observing tooling, using AI providers, building AI capabilities, using different frameworks. There's a whole bunch of options on here. There's a whole bunch of things. Playing an online strategy game called Generals 0 Hour. 2003. Hater. What? Whoa, that's crazy. That's great. Look, you guys, look, it worked. We did it. Hey, Neva, look at that. We did it. We were just like talking, and in the background, our AI just magically did the fine tuning. It got the right answer. Hey, look at that right there. We did it. That's the correct answer. Oh, that is so amazing. Right here, you guys. 1.41 million. Oh, we did it. We fine-tuned the AI model to learn how to do math. Isn't that great? We did it. Thank you for the party poppers. Oh, that is very satisfying. Oh, Sunday complete, you guys. Sunday complete. We did it. How do you... that is very sad. We did it. I did fine-tuning. Hey, look at that. We did some low rank adaptation fine-tuning. Thank you for the party poppers, you guys. Oh, that is so fantastic. It was just sitting there in the background. Steven, you forgot to remove the blocks.ai hackathon text. Oh, well, it's still happening, right, Loons? It's still happening right now. So we have blocks.ai hackathon. It's happening now. Ask about it. In our Discord channel, we've got a hackathon channel. Blocks.ai, you guys. You go to blocks.ai, you create an agent, make it public and active. Submit the agent to the Discord channel, and you will be entered to win a pool of prizes. Ooh, can we teach it fun stuff now? We sure can. We can teach it whatever we want. We sure can. What was your mental state after the failure? How did you move on? I played some video games and ate ice cream. That's what I did. I played some video games and ate ice cream. And you know what? Here's the deal. All right, check this out. Just slide in for a second. I have run into failure almost every day on a regular basis. And it is a not good feeling, right? Oh no, you failed. It's terrible. You know what? It's actually okay. After a while, you start realizing where you made the mistake, and you gain a new ambition to continue onward and try again. Try again every single day. Keep going. Don't give up, because that giving up will mean guaranteed failure. The thing that keeps you successful is persevering after your failure. That's it right there. You got to persevere after you failed. It's okay. Just try again. Yes, what it is, you guys. That's what it is. I'll help you once I retire from Amazon. Sounds good, Jeff. Or wait, Jeremy. Sounds good, Jeremy. I said I got too excited there. I got too excited. Jeremy is your name. Can you explain what just happened? Yes. So I will. I will explain what just happened and why I was so excited. Why am I so excited, you guys? Because our AI model got the right math answer. You build bedrock breakers in Minecraft, and I have a YouTube channel for it. Oh, you do? Really? I use bedrock. I like bedrock. Build bedrock breakers. So basically you're saying, are you running Java or Bedrock? Obviously you say Bedrock, which is the unbreakable stone, unbreakable blocks, right? These are the unbreakable blocks. And you can build a machine that can move those blocks, or does it actually break them? Aditya, thank you so much. Hey, Shravana. Hey, Shravana. Hey, Steven, how's it going? Where is the data? Here, I'll show you. All right, let's close that. All right, by LoRA. We're going to walk through what we just did. You mean Bug Rock and... All right, Bug Rock, yeah. I like Bedrock. I would love to see your channel. You got rejected 150 times. I just pray to Lord and forget. That's the way to do it, Jeremy. Exactly. Failure is going to happen constantly because you're at the frontier. If you're at the frontier of sciences, you will run into failure. Not just professionally, but also in your day-to-day. All right, Fiber Brian, I'm going to explain what just happened. Are you ready? Let's see. I'm trying to see if I missed any messages, you guys. Currently 6th semester. How is it possible to join you? Are demotivate to join you? Ashish. Well, we might have an internship open. That might happen. It's not a for sure thing. I'm still figuring it out. If we have it, I'll let you guys know in the Discord. Okay. Discord, yes. Hey, stand-up comedy. Wait, stand-up comedy lure. Comedy lure. Hey, stand-up comedy lure. How's it going over there? Discord, yes. You can see there's a pinned message. I'll also send the Discord to you guys real quick. Copy link at stand-up. There you go. What would you suggest me pursue masters in USA? I actually don't know. I don't think it matters as much, right? If you have the opportunity and you think it's better, jump for the opportunity. Don't let it pass you by. Stand-up comedy layer. Yep, you're welcome. Stand-up comedy layer. How do you manage your time? Hater. So I spend some time on stream, usually doing what I would do off stream, which would be reading things, learning new things. So that's part of my time management. Additionally, I wake up early at 4 a.m. every day, and I make food for the entire day. I prepare it for the entire day. And then I go into a bunch of meetings, I work with teams, I talk with customers, and then I do a little bit of streaming. Bye, man. Good night. All right, sounds good, Fiber Brian. I missed, so I am going to walk through this here real quick. However, if you want, we can walk through it later. It's fine. I'm going to do it right now, though. I'll do it right now. Depends. Okay, here we go. All right. So LoRA is a monkey patch function that I've defined in Python here. It's going to freeze the model weights, and it's going to override, it's going to monkey patch the forward on all of the layers of the model, specifically the linear layers. And we define a rank, which is the low part of a LoRA, low rank adaptation. This is going to reduce matrix size by a rank of 4, which means it's just going to have one of the dimensions will be 4. So instead of like a dimension 100 by a million, it'll be 100 by 4. So it's a dramatic reduction in dimensions. Alpha is just sort of a mutation on generating a scale on how much we should upscale the output from our LoRA layers, which are here. These parameters are 2 matrices, which have the shape input from the input of the forward output on the model itself, and the rank is going to be the smaller side of that matrix. To make them fit together, I put the rank on either side for the LoRA in and out, which is the LoRA A and B. The output shape needs to match the original model. I have pinned the layers to a parameter list, and then I freeze the parameters in the original model. I look only for the linear layers, and then I generate LoRA layers for each of those. I define a forward, which is going to monkey patch the original model, and I replace the layers forward by performing the original forward using the input with the model's original forward, and then I also calculate the exit with the LoRA layers, including the scale, which scales it up. I return the output from the LoRA and the original model. I add them together, and this is where I monkey patch. And then I return the mutated monkey patched model along with the LoRA layers. Then we just do normal machine learning going forward from there. We get the tokenizers and the model itself, which is going to convert text into tokens. Then we've got our model, which is a Quinn 2.5. I do the monkey patching. I define a loss, which we don't use actually, so I can get rid of that. I use multiple optimizers, and then I have training data, which is going to train the model on how to do a hard math problem. Right there. Oh, Loons, gotta go. All right, see you, Loons. No, explain it first. Yep, Fire Brian. Yep, we're explaining. Then we get our test message to see if the model learned the assistance response. We train it over 100 sample steps. Really straightforward and easy. And then we test it to see how well it performs. And the test showed that it worked. You can see that it got the correct answer. Right there. It got the correct answer, you guys. We did it. We got the correct answer right there. 1.41 million. It did it. Can you share? Can I share in Minecraft? Yes, you sure can. Absolutely. Share it in Discord if you are interested about the redstone magic and breaking bedrock. Absolutely. Let's do it. Share away in Discord. How much hours of productivity do you learn extra per? So I work around 10 hours a day and then study maybe 2 to 4 hours. So about 14 hours a day. And that's like the average. Thank you for the party poppers, you guys. I'm so happy we did it. We fine-tuned a model. We did it. And we fine-tuned a large language model too, right? It's one of the hard things to do. We did it. The least squares. Oh, stand-up comedy. What do you mean the least squares? Are you talking about... I missed it. I missed your message. Are you talking about the scaling? Right here, the scaling? Which channel should I share? The Minecraft channel. I mean, whatever channel you want. It's whatever channel you want. Interesting stuff, Steven. Nice. Dimension. Yep, dimensions reductions. Yep, you got it, Jeremy. And optimization using low rank adaptation. We did it. Man, your enthusiasm vibe is exactly like mine. It kind of resonates with me. Hey, that's great to hear. That's fantastic. I'm so happy, you guys. We did it. I fine-tuned a model. Hey, look at that. And I used low rank adaptation to do it. Which Discord channel? Oh, do this one here. Oh, wait. So here, I'll send it to you at m_. There you go. Hey, Sergio, thank you. Sergio. All right, you guys. We succeeded. So glad that you're all here. We had a lot of fun today. We achieved our objective. We did it. We fine-tuned a model using low rank adaptation that we coded from scratch. We coded it from scratch. We did it, and you saw me do it. You saw me do it right here live. That was so fun. See, now I'm going to have a good rest of today because I feel accomplished now. I feel like I achieved something. Thank you for the party poppers, you guys. All right. So the plan for tomorrow, we'll probably begin our transformer journey, building a transformer. We'll start training a model directly using the PyTorch transformer. It should be pretty straightforward. Good night, sir. All right. Thank you. Stand-up comedy alert. All right. Sounds good. Thank you. Glad I got the confirmation. Happy seeing the code. Yep, we did it. We did it. The code sparkled in our eyes. Code really brings tears in my eyes. I know, right? It's so great. Good night, mister. All right, everybody. Thank you, Jeremy. Thank you, Jenya. Thank you, Aditya. Loons. Everybody. Let's code, guys. Jeremy, stand-up comedy alert. Which text channel? Oh, usually link share is best, right? Hashtag link, share. Link share is the best. I like link share because you're technically sharing a link. So it's appropriate, right? You look like Sam Altman. Hey, random 52081. Good to see you. Welcome on in. You joined right here at the end of stream. We are headed out. We are building more AI tomorrow. So we just finished. We succeeded building the low rank adaptation fine tuning. We did it and we proved it. We proved it right there. We did it. All right, you guys. Thank you so much for joining. I'll be back tomorrow about the same time. And we will be building more AI. Let's do it. More PyTorch. Thank you, everybody. Have a good night. Bye, everybody. See you tomorrow.